Okay, so yesterday I set up this skeleton that uses Cairo window. And now we have to begin with configuring the project in main. I mean, yesterday I did just the build system, so everything here, this stuff and all the sub modules that I needed. Let me see. Of course, I need an example, and I think the only example that I currently have is my machine learning project. Or maybe there is some documentation for Cairo window itself. So this is the README of Cairo window. It just says what it contains, so it's totally not useful at the moment, I think. Yeah, this is what I all did. There's basically no documentation here. But it says, check out machine learning for an example. So, blah. So we find something. Tests, maybe? I don't think so. Is it Cairo in itself that has test examples? That wouldn't surprise me, because I don't see anything here. This is maybe all machine learning. So we go back to Cairo window. Yeah, that has a test. Let me click on that. So let's use this. It starts the same. The initializing libcwd and then printing entry main. We already have that. So I'm going to copy this. I have in a try block. Hello, Vinayak. Create a window. Get a background layer. Do something on the background layer. Well, okay. Can have a second layer. I need an event loop. Do a line. Create a plot. Let's not go that far. It should already open a window and draw something. It's a good start. Still need to close my try catch block. So let's go down. Yeah, we probably want to wait. Not immediately exit, because I think this copy. Let's uncomment this. What is it doing? A red square. Okay, let's just do both. And then see where it all goes wrong. It's totally not going to compile, of course. Forgot all the headers. Well, which header are we going to need? I can definitely copy that as well. This thing has a lot of headers, but yeah, we have a window and a layer and a. It did not have a plot actually. It did have a line though. I think I'm gonna need these for sure. Seems I'm using a rectangle and a line. I don't see a rectangle here. Let's just do the line. See where it goes wrong. And I mean, this is being used, and that is needed to print it. Maybe you have that as well. Color pool, yeah. Well, no. These are used for sure. Let me see where it now goes wrong then. Okay, we clearly need shape. This one. No matching constructor initialization of draw line. Yeah, well, that's weird. Let's have a look at what I'm trying to pass here. Oh, that was commented out, so maybe it was so old that it indeed broke. So line in the namespace draw. This is line and this lives in namespace draw. No, it doesn't. This lives in plot. I want to go to draw. That seems slightly weird. I don't know. Draw line. Yeah, I wrote it, but I forgot everything about it. I was like, why would I use a line from draw if I also have a line in plot? And I forgot the differences. I think I have a line in math, which is just a mathematical line. And then we have a line in plot, which is the lines that you can plot. And then a line in draw is just internal thing that is being used by the plot one. That's what I thought. And well, maybe that's just wrong. Actually, you need to use draw and plot is something in the background. Let me just go with the draw because that's what it's doing here. Here I have a line which lives in namespace. Yeah, okay, arrow window draw. There's only one constructor. I bet this draws a line from x1 y1 to x2 y2, and you need a puzzle line style. And that is not what I'm doing here. Nope, I'm trying to pass an object. So the other line then. That is the math line. Though this takes a math line. See, that would make, in my eyes, it makes more sense actually to create a math line that describes the line, and then construct from that a line in plot, which you then can plot probably. This is a wrapper around a draw line, so I think I should look at some code that is not commented out, so I know what is the latest way to do this. Okay, where did I find this code? I found it here in a test. Let's go to a more think that is later. I think that this is probably later, and then you can only use plot when you have a plot, I bet. That's why I use draw directly. Also, this uses draw, but okay, that's the draw line style. I think that's the reason. I don't have a plot. So we started so simplistic. Well, simplistic, I mean, we started without a plot. So I'm not using plot, but but I do want to draw something, so then I just use the line from draw, which apparently now takes the coordinates raw. No matching member function for call to draw. No, why did I have to start with broken commented out code? I have a better idea maybe. Quit print environment, and then I want to add tests, I think, which I did not add yesterday. Okay, so the test directory here. Era window tests. Reload my environment, and then make C tags. Now it should also have all the tests in it. Then we can grab sources for anything with the draw, maybe. Rather, I wanted to see how to draw a line. Let's see, we have another line here. Line plot. Nope, it's the only one. Seriously. And my copy. No example. That's annoying. What's the other one? Shape. This looks a lot like the same thing, doesn't it? So instead of passing a pointer, it probably just should be a shared pointer. I mean, this one compiled. So I have a draw function. Takes a shared pointer to a later region. Oh, a pointer to a multi-region. Totally possible. The question is my line a layer region or a multi-region? I would say a layer region. Point, maybe draw point. Doesn't get any simpler than that. Point. Nope. I never use draw directly. Basically never. So that my first instinct was correct. That should not use draw. You should use plot. But I don't want to create a plot just yet, because really I want to just draw something. I don't want to make a plot. I just want to draw lines in this case. Yeah, line, rectangle, text, no plot. A plot would be something with an x and a y axis that isn't rotated. And I want to have rotated coordinate systems. That's what I want to generate. So I don't want to use plot. So apparently I have to figure out how to use the namespace draw directly. Okay, what was the current problem? Because I forgot. Oh yeah, right. So we need to know this line here, that doesn't work. No matching function will call to draw candidate function, no known conversion from line pointer to. So it's not a shared pointer and it's not a pointer to a multi-region. So probably we should make it a shared pointer then, but only if line is derived from a layer region. I mean, it's not derived from multi-region, so come on, has to be derived from a layer region. Please let it be derived from a layer region. Where's my line? Yeah. So this line, draw line, it's not this one, it's plot line. Yeah, derived from layer region. It becomes suddenly way more clear. So I have to do the same thing as here. Auto. The draw line was just like one of the first examples that I ever coded. Then I commented it out and never updated the interface. I think that's how it worked. Blue line, make shared. Draw line. And then we can draw the shared pointer. Expected catch. Oh, I've got to copy the catch. No. What? The catch is here. Oh, we forgot a closing thingy. Where did I get this from? I forgot that as well. I think this one. Yeah. Is it the end of the try? No, this is the end of the try. The event loop closes at the end of the catch. Of the try catch. Try. Try stuff. That's just embrace too much. Do I still want to wait? Do I not? I'm not sure. Let's start with commenting this out, see if it indeed immediately exits or not. Okay, it compiles. Yay. Now we have to fix the linking. So we have to do 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 the linking. So we have to Undefined reference to debug Cairo, blah blah blah. I guess that's part of Cairo window, or you're just not linking with Cairo window. Well, that's how it looks like. So my guess is this AI CXX Cairo window. Yeah, or not. VI Cairo window /CM. I guess that's correctly. How about that? Undefined type info, symbol expression, symbol. That means that it didn't generate the virtual table, and that means that we don't have all the virtual functions defined, apparently. In other words, these things are incomplete, and that happens here. 41. Symbolic. No. Symbol. Well, in both cases it is symbol. It's just symbol, isn't it? Type info is symbol. Okay, yeah. Let's begin with symbol then. Well, that can't happen, obviously. I mean, symbol is just defined. Symbol depends on expression. I mean, that code breaks. I didn't use this for a year, and then you try to compile it again, and it suddenly doesn't compile anymore. What? Why? And then I want to figure out why. Because what changed then? Something must have changed. It doesn't make sense that a class like symbol suddenly loses a virtual function, obviously. Don't even see the word virtual here, nor override. Oh, I do see a lot of overrides. But yeah, maybe I forgot one. I think symbolic printing is defined. It could be to say the base class is defining a print on as an pure virtual function, and then this class is not defining that because that macro is not defined. So you have a look at the expression. Loads and loads of virtual stuff. Loads and loads of pure virtual stuff as well. All these equal zeros. So which one is missing in symbol, and how the hell is that possible? No, that must be a linking problem. It did compile. Yeah, it's a linking problem. Excusez-moi. It must be a linking problem. Because if a virtual function is not defined, then you can't create it. Then the compiler would have said, sorry, but you can't create a symbol because not all virtual functions are defined. I think the problem here is that the type info, which is kind of, I think it ends up in the same translation unit as the virtual table, isn't found. Now, where would that be put? I guess, well, somewhere related to Cairo window symbolic. Maybe symbolic has its own object library, which we didn't get. You have to link with that as well. That's probably it, yeah. I should be able to see that in the only project that I have. That uses GUI window. So let's have a look there. Machine learning, ding ding, and then GUI window itself actually. So I don't even need to go in this project because I have machine learning. GUI window in the new project as well. I just have to look at the tests, CMake lists. And no, everything seems to be linking with... Oh, yeah, there it is. If you link with GUI window, you also have to link with symbolic. And math, before we forget it. And probably eigen as well. This is the most likely one though, that is not linking with eigen. So we are missing these two. I put GUI window in front of that one. Yeah, actually makes sense. Okay, just a linking problem. Go here, VICM. So that one is at the bottom, and then we are missing these two. Like that. And now it compiles. Yay! Now, let's see what this does. We finally get something. You get a window. It's not immediately closing, and we have a rectangle and a line, a blue line and a red rectangle. Pretty awesome. Can resize the window. Can close it. If I run it again, it's big again. Remember dimensions. Save on close. Well, it probably my program then. Just my program says open it with that size. Well, why not? Maybe a bit too big actually. Well, let's make it half the size. I mean, I'm going to draw images that need to end up in a Stack Overflow answer, or it can't be much bigger than this, I think. There's my window. So let's make them 600 by 450. Yay. Absolutely perfect. Now, my question to the AI was give me a square that is... What did they ask for? It couldn't do it. It gave me a wrong picture here, which looks nice. And then it gave me a horrible looking picture. It's absolutely horrible. But more or less what I asked for, yeah. So what I asked for was the rectangle must be 200 pixels wide and 100 pixels high. Well, there we are, the rectangle. Draw a rectangle of 200 times 100. Okay, let's call this rectangle 1. And this is, I think, the position, and this is the width and the height. 200, 100. Let's see if that's true. Width and height, yes. And color, let's just use black. and then draw that. With rectangle 1. And I draw this one in the background. Yeah, well, I don't really need a second layer, I think. In fact, the background is more suited for the coordinate system. So maybe you should draw this one in the second layer. Let's call this item layer. I'm gonna call it item draw layer. No, I'm gonna call it a draw layer at the moment. So I need multiple layers. Why not? Let's call this a draw layer. But then again, if I have a background, if I have only one background, I'm gonna have many different coordinate systems. So maybe I want one coordinate system to be on top of the other, but I can probably manage that by drawing them in the correct order instead of using layers. Layers is more to speed up something. Like if you make changes, I mean, yeah, and I'm just gonna draw it once, and then there's no animation even. So I don't need any layer. I just have to draw the stuff in the correct order. Let's not use any layer. Yeah, okay. So no layer. Let's call this the layer. Background. This is totally not gray, it's white. The white background. Rectangle, blah blah blah. Sorry, this has to be layer now. Yeah, I might as well do all the drawing after opening the window already. That works. So open the window and start drawing. Well, there's nothing to draw then, but if there was something to draw, I would start drawing. And then we add this. And then I want to draw the coordinate system first, and we don't need that one. Okay, so I want to have an origin. Let's define, everything is using coordinates separately. I have a point, of course. Should I create a point? Well, let's not create a point just yet. So I just make a constant. Doesn't even need to be a const expression, I think. Pixels, so just an inch. Draw. Origin. X. I think that everything I'm going to define is in pixel coordinates, the way I'm doing it now, which is rather annoying. I would rather have immediately the correct... maybe I can link with Qt and just use the... use Qt itself to do all the coordinate transformations. I think that's a cool idea. Yeah, let's do that. So the origin in draw coordinates Let me see. So I want to do a transform on points. I could even do a transform on a rectangle. Let's begin with points. So I want to have a point. So in the end, so yeah, it must be a class. A point. So this point has 2 coordinates, private. Nobody can touch them. It's already private, but well, that's my habit to type private anyway. Let's use Qt. Okay, so I'm gonna do everything immediately in QReals. As of yet, I still don't know if these are floats or doubles. Oh well. X and QReal Y. So, that's going to work. I need QReal to be defined, which means I need to include some Qt header. Let's include Q transform, because that's something that I'm definitely going to use then. That should define QReal. And then I think everything should work. Except that it shouldn't link, because I'm not yet linking with Qt, but let's see if this compiles. Q transform file not found. Oh, that's quick. Okay, yeah. Yeah, I need to add a Qt then. So let's steal that from here. Adding Qt works as follows. Probably need this policy as well. Just copy everything. I have a policy and then find Qt. I don't think I need the user interface here. Yeah. And then so this is not needed. This is the library, and then in the end you just have to link with Qt widgets. Here's an example as a test. So I dropped it after the objects list. Okay. Top. Link with Qt. I was in the middle of writing that. Cool, now it links with Qt. Okay, so what I wanted to do is have different points that have different type as function of the coordinate system that we are in. I have a namespace called draw. Let's just make this a class, enum class. So now we should be able to create a point of that type. But in order to do that with private stuff, we need to add a constructor. So have a constructor that takes a QReal. And then we are able to create a point that knows which coordinate system it belongs to. And see how if that works. Well, I'm lazy. I want to copy this. So point, coordinate system, draw, origin 0,0. Well, let's add a default constructor, which is then automatically the origin. Let's put it somewhere here. And I was calling it draw origin, so draw origin. However, in the end, we're going to do, well, this probably works. Yeah, I think it works. So I'm going to do a translation from draw origin to item coordinates. Then you get something that is the draw origin in item coordinates, which this is very confusing now. Let's call this point P. Okay, so we have a P. This P is in draw coordinates, and I think you should have to put the draw on that side. But that also means that it doesn't look right. Huh? What do it like this? It seems to make more sense. So. Say I want to convert P from draw to item. P is P. I mean, there's just one point in the universe. And the coordinate system is virtual. So, say this is the center of Earth. And we have it in draw coordinates, and now I want it in item coordinates. So we just have two coordinate systems, but the Earth is still the same thing. And then the conversion is something like a transpose times that, and I want it to look like this, so we can short circuit it. Now you see that the T can be multiplied with a draw on this side, and then it gives an item on the other side. That's my way of denoting this. However, I once wrote a document about understanding rotations in Second Life, which is very much the same. Now we're talking rotation is a transformation as well. Now we include scales and stuff, but okay, same idea. Conversion between coordinate systems. And I ended up, I'm pretty sure, with something that had to draw on the other side. So you get draw like that. So it looks much better. Just short circuit this here. But yeah, I mean, then this item should be on the other side. So I just moved the problem from one side to the other. Or do I? Because this is a prefix item, and this also has a prefix item. Well, maybe this looks better. Yeah. So the which coordinate system it is goes in front of the item. Item, point, whatever, the thing. because that way we can multiply it from the left with something and then match these two. It's just a notation, but it's going to help a lot, I think. Right, so this is now 0, 0. We want to go to my window coordinates. So I need to transform between say in the end I need to end up with a point in the coordinate system that I can use here, which is yeah, this application. So nothing to do with Qt. This application isn't really using Qt. I'm just using Qt for the Q transform class. So how shall we call the coordinate system that we draw in? Or you could call it viewport or device, but that would be too Qt-ish. Let's call it can't call draw. I mean, I have a namespace draw here as well. Image, maybe. Image or picture. Picture. Window. Some stupid word is probably better. I think. Show. Let's call it show. Who cares? So now I have a show something. But the something is the origin of the draw coordinate system. So normally you only have real objects like the Earth. The coordinate systems are virtual. However, I need to draw a coordinate system in this case. So suddenly now the coordinate system itself becomes a thing. Now I could of course say this is the draw origin in show coordinates, but then this looks like origin in draw coordinates. So maybe I need draw here twice. To keep the two draws apart, I'm going to capitalize one of them. Or maybe connect it with the origin. Draw origin. That looks good. So this is the draw origin in draw coordinates, aka 0, 0. But I still needed to do it because we need the correct type. Otherwise I can't convert it easily. And then this is the draw origin in show coordinates. Of course you have to create it. So in the end this is going to be a multiplication then to show. And the transform is, yeah, just transform. Oh, wait a minute. No, draw. Times draw. So these two short circuits, and then we end up with show draw origin. You know, it's almost English. Now I have to define this, of course. So yeah, let's be lazy. This is some type. We don't know what. And we can create that from think some external object that defines how I want to draw stuff. Uh-oh, I don't know yet. Right now I don't want to... Well, scaling and rotating has no meaning yet, because it's just the origin. Only translation has a meaning. And where I want to translate it, let's start with an identity matrix and then apply a translation. That seems to make sense, right? So I'm going to define a transform, which is by definition identity matrix here. And I'm going to apply a translate on that. And the translate is basically these coordinates. I want to end up at 50-50. However, should this be 50-50 or should it be -50? And I want to do this a bit in the Qt way, the same way as Qt it does. So if you go from draw to show, and I want draw to be shifted +50 relative to show, that means that 0, 0, so that this must end up as 50-50 instead, and not -50. I think I already wrote something about that. I've got it, but I wrote it yesterday. Typical. Let's find that back. Yeah, I was writing here. I think I can copy it from the program that I used to generate this. Like here I say, where do I say that? I'm not going to read everything. Yeah, after. So the call setPos behaves the same as a final translation that occurs after the scaling and rotating. So we're talking about a transform involving a translation. There's only two possibilities. Shift is one way or the other. I don't want to get it right immediately. Let me see. I had written this transform test. Here's a setPos. This is done afterwards. Yeah, this is not what I want. Or is it? Oh, these are the only ones I have, yeah. But okay, we have just a single thing. I can ignore the rotation, the scale. So let's say setPos here is the translation. And then apparently if we call set pos, so I have an item. The item is at 1010, and then we call set pos on the item, but that is basically the same as the translation, at least if you print it as the transform. So I'm going to print T2, I hope. No, I'm just printing the map of the T2. So how about I just print the T2 here? T2 is I2 set pos. I'm not convinced. Let me print the actual T2. Excusez-moi. What the hell? Oh, trend form. It's again trend form? Why is it trend form? Did I never rename this file? It's what? I mean, I know I forgot the S at some point, but then I fixed it. How is the file still called trend form? Nah. Let's not think about it. Transform. Transform. Transform tests. Yeah, these two are indeed the same thing. So we end up with this matrix, which means that if you map some point with it, I think the result gets 2 and 3 added. So do you see that here? T2. There it is. So if you have a point at 1010 and I apply the transform T2, then the result is +2, +3 for x and y. In other words, these values, which happen to be the same, these two values does end up here in the matrix, so it doesn't matter. So if you do it translate and you mention two positive values, then it is the result that gets incremented with these values. So that's what we want. We have the origin, which is 0, 0 in the draw coordinate system, and we want to draw the origin at 50, 50, pixels in the show coordinate system. So the 50, 50 is being added, so the origin ends up at pixels 50, 50. Okay. Still have to write this part now, but I can probably add trend form. That's really trend form. I have nothing against trends, but I just forget to type the S. Okay, so now I have the show draw origin, which is 50-50. This is a random line, so ignore that. Now we want to make a rectangle out of that. And I have no clue which namespace this rectangle comes from. Must be GUI window. I don't have any other thing. Doesn't even matter that much. So let's create a rectangle, and this rectangle represents our item, but it is not in item coordinates. It's in the coordinates that we draw in. Let's not call it item, therefore. Let's call it object. Could call it rectangle, but it's also rectangles are used all over the place for stuff. I'm gonna call it object. Okay, we have an object, and this rectangle is defined in show coordinates. And this rectangle, it lives in Cairo window and has a constructor that takes the origin of it and the width and the height. That's it. So we need the show draw origin. So draw a rectangle of 200 with the top left in the origin of the draw coordinate system. aka draw origin. So we need accessors because we must pass this as x and y separately. And then we need the width and the height. Now the show coordinates here are the pixels, and I wanted the whole thing to end up as 200 and 100. So this is where I should enter the 200 and 100 values. Even though in the end I probably want to convert that back to the draw thing, but yeah, I want to draw it like that as well. So so they are the same. There's the scaling between show and draw is 1. So far so good. Okay, stuff is missing. Okay, I don't have a show yet, but that's easy. I just add show here. And I don't have accessors yet. And yeah, I probably want to be able to print it at some point. So I'm gonna do here void print on. That's my system. Standard O stream. Const. And then we just print, I just print the values, I don't know. Actually, I have to print the coordinate system as well. Then we need, oh my god. I have to document at some point, I can't remember it anyway. So, how to print enums. Yeah, it's a fact of life. I want to print this enum. Actually, I remember it now. I use utils for that. Yeah, utils, print, enum, I think. Oh, no, not print. Forget it. ToString. Yeah. That's probably documented. So this prints a draw or show. And then let's say a colon and open thingy, and then we print the values. X, comma, Y. And then closing this thing. Now for this print on to automatically be picked up, if you try to write this object to an OStream, I need another utility called print on. We need to add that in global namespace. That is an indient operator that is actually being used. And then this operator will use this member function. But that requires a header, and the header is this. We have another header. That is the ToString. And that one requires also stuff. Okay, window, utils bit set, vector index, has ToString. This is huh? Has ToString. I think I need a ToString. Oh. Yeah, like no way. Is it has ToString? Yeah, include has ToString. Use a class that no, that's not it. Where did I define the ToString then? Must be ToString. Can't find it. Let's look in the header itself directly. Yeah, it exists. Add support for printing enums by ADL. For this to work, you need to add enchantum.git or fork that. Copy to the root of your project. I'm gonna add my own, I think. Although, might as well add the ZX Shadys one. I'm gonna add my own. Maybe sync it with this one if it was changed. I don't know. Submodule add. Another submodule has been added. And add submodule enchantum to CMake lists and link with it. That's all. Add subdirectory, I did it wrong. Where did I find it? Not here. I did it right. I added this. Enchantum. What do you mean there's no enchantum? Transform. Oh, I added to the wrong one. Enchant them first. And fatal config.h not found into string. I would say that is the job of CWDS to include, although maybe it's a bit too much to ask, isn't it? I don't know. The problem is you have utils config defined, and then some header has to include this config because this is defined. And I thought that happens in... Yeah, that happens here. So apparently that is not included. Ah, I remember now. We ran into that yesterday. That means someone is not linking with CWDS, but with utils, and now you have to link with both since a recent change. So who would that be? Utils itself. Ouch. Oh, brilliant. Yeah, indeed. Oh, wow. The error happens in utils itself. So utils are no longer linking with CWDS. Therefore, anyone linking with utils now also has to link with CWDS itself, because it doesn't get it through utils anymore. But CWS was taking care of including the config. It's like literally the only place. So this thing is generated. Now normally, I mean, this is in utils, source directory. And normally you would think if then you use double quotes, it finds it. But what is in the same directory is config.h.in. And then config.h is generated from that in the build directory. Therefore, we do need an include directive, -i, for the build directory. And that is then the root build directory /utils. But we don't have that anymore. Well, we don't have that at all, ever. So, I think the way this used to work is that this, because utils was linking with CWS, this would then include a config from CWS, probably. And then in the end, via accidentally get the config from utils, so something like that. So yeah, not good. I think if I do utils, it will work. But is it? Because we are, at this moment, compiling utils itself. So the include directories that adds are the same include directories that it gets from CWS. Which I'm pretty sure includes the build directory as the first one. Yeah, it's okay. That's working. That should work. So that CWS was not including utils as obviously. So that's just config.h. It was impossible to work. I just have to use. It's kind of nonsensical. That's it. Otherwise, it starts to look weird in my eyes. Because double quotes just means look first in the directory that this source file is in. And I have started to use double quotes to mean something else, namely I wrote it. But sometimes things get so complex that this was also not really a good hint then, because if anyone looks at this and then copies it, which is not me, then they would use double quotes as in Carlo wrote it. Nah. I don't know, man. It should be angle brackets. Yeah. So I'm going to use that in the documentation. Maybe I'm even going to switch completely away from using double quotes for I wrote it, and just use double quotes for look in the current source structure. Point is ambiguous. Candidate found is the one that I want, and then there is one in Cairo window. Yeah, because we are using namespace. Cairo window. Although that one is not a template. In other words, we're going to remove using Cairo window because it just drags in too much. But we do need stuff like window, we already have that. Layer, or maybe I should put Cairo window in front of that. Color might be from there as well, most likely. So color. And rule. No. Can I do using for a namespace? Using namespace draw? Maybe. That looks about everything, right? Let's try it. No type named color and namespace Cairo window. Did you mean color? Then what the hell is color? It has a color, green. Haha. Can jump to it. Namespace color, Cairo window. Color.h, it's a namespace, but you can't include it like that. That's probably the same problem with... I should know that, of course. How do I do that? Like namespace, I think. Namespace color is that. And then this one too. Just works. And event loop, what did it say? Event loop also in Cairo window. Okay, event loop. Okay, use of undeclared identifier transform. I didn't write that yet, of course. That is definitely the last thing then that we need to add. Or definitely that's not the last thing. But before this, the next time it compiles, I definitely have to define this. Transform. My new class. And that thing needs to have a default constructor, which it now has. And then I'm going to call translate on that. And the result is again a transform. So I have transform, reference, translate. QReal dx QReal dy return this, And of course this is going to wrap an Q transform. Let's call that just M. The M of matrix. And then the thing that is returned is multiplied with something. Also, this thing has 2 coordinate systems, so it must be a template. Show draw, because it says show and draw here. Or the other way around. It says show and draw here, and then we copy that there. Translate, yeah. Okay, next. Do I want to be able to print this thing? Maybe, probably, just do it. To CS transform from CS and then just print M. Which means we need to be able to print Q transforms. Which I was able to. This is not where I want to be. Here, transform tests. Let's just copy this. What else do we need? Oh yeah, the multiplication. Oh, I don't have that here yet. Well, the multiplication is a call to a map on the Qt. but so you have an map only have a point. Okay, so we're going to return a point of 2 coordinate system if you call operator star on a point of from coordinate system const reference point does not change our matrix. Return, and then you need to call a constructor of this point 2cs, which takes an x and a y. So the 2x and the 2y. I'm going to have to call this, where the T1 is our matrix, and the map is a Q point, of course. So Q point F P, and then we map it. And the result is another Q point. Let's call that R, or the R of result. And I might as well do R dot X and R dot Y. And this P can most likely be constructed from the X and Y coordinate of my input point. I think that's the multiplication thingy. I must forget something, but well, the compiler tell me. I forget. Well, come on. Undeclared identifier show. Yeah, that's because it's a class. Coordinate system gets a bit big now, doesn't it? It's not a faster way to do that. Wait a minute, something is not right here. No, I'm afraid that's it. Okay, what else was missing here? Rectangle is missing. Oh my god. I'm disappointed. Oh, this is probably 200 pixels and 100 pixels, but it's totally not offset by 50-50. And does this line really start at 100? So the positive y-axis is down, huh? You know that. So does this point start at 100, 100? Looks like what's in the middle, yeah. So it's probably from 100, 100 to something. The blue line is totally not starting at 100, 100. Well, actually it is, because this is not a width, of course. So it's from 350, 250 to 100, 100. So draw the other way. Oh, duh. But we don't have an offset. Why? My coordinate transformation is not working. Shocking. Well, let's start to print everything. So the out, DC, notice, door origin is. I'm gonna enjoy this because that should already work. Compile. It compiles. Isn't it beautiful? Yeah, see, the draw origin in draw coordinates is 0, 0. I totally agree with that. And then we can print the result here before drawing it. Let's actually here. The show origin in show coordinates is, that's going to print 0, 0 as well. Apparently, because that's where it is drawing it. Yep, that should have been 50-50. Control Q is not working. Well, then no more procrastination, or how do you say that? Uitstel? How does this matrix look like? Well, it's already beautiful if you can print it. And we can, maybe, probably. Yes. Okay, so the show, sorry, the from draw to transform, sorry, from draw to show, transform is, and then it repeats that because it knows what it is. Maybe also add a colon here. And I added a new line here because, yeah, the thing is 3 high. It would be a bit much to get that to print here. Or worse even, that the colon is in front of that. I could do that, I think. But it would be too much work. And it is totally the identity matrix, so that's the problem. Printing it, so you could add it in front of this, I guess. How would that work? Could add a custom OStream manipulator. Set the prefix on the OStream and then print the Q transform. Nope. Let's not do that. Yeah, or wrap it anyway. Why would I be using that? Do I want to print Q transforms, or do I just, I mean, this is a wrapper around the Q transform. Why would I want to be able to print a Q transform separately? I'm just gonna print transforms all the way. In other words, we're going to replace the above thing with this function, and then we can put the prefix where we want it. I think that's a better idea, yeah. Okay, let's no longer be able to print Q transforms. Remove this. and just put that here. And then I want to print the prefix, which is this. Let's print it to an O stream string. Let's give it a name. Name. I gave it a name. What are you saying? What is your problem? That's not a name. Well, it is a name, but I want to change it into a prefix. It's no longer the name then. A prefix is the name with a colon after it. And then this is the standard minimum of the length of this thing. And what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm gonna say 24. And then we need an O stream string header. And I think math for the send and min, or no algorithm. But I already have that included, I bet. Nevertheless, this file is using it too. What was I saying? We need it then. Do you believe it? I forgot it again. Algorithm, and the other one was, oh yeah, string. String. Yeah. I said it right when I included it. Nope. Oh well, actually string is a size type. Annoying. To hell with it. That my result is also an int. On declared identifier transform. Yup. Now we are talking about transform is m underscore. Substitute transform m underscore. And the name is gone. Prefix. I broke it because I forgot to add a new line. Yeah, my whole new line is gone, isn't it? New lines, you can't just add new lines, man. You can't add new lines. Arg, this is so not working. I can add new lines here. Normally I cannot add new lines in the middle of a debug output. I have to think of a way to enable multi-line debug output, I think, because every now and then I run into it. Yeah, just start with printing a new line. Now it's aligned wrong. How do you align it to the right? It's standard right or standard what? Command try standard right. Which, if it exists, reminds me that we now very definitely use I/O manipulators. That was already dragged in via debugging headers, maybe. Hey, just compiles. What about that? And it's still not aligned to the right. The standard right probably applies to the rest as well then, which we don't want. So let's put it back to standard left here. Although might as well use right. For nah, I don't know. Oh, well, brilliant. Yeah, this is now aligned to the left. So what? So, no, what? Nothing works. Arg. I think this is pretty much written correctly. This is definitely not shifted to the right. Still not. And now this is shifted to the left. Yeah, I don't want that. I want to do this. What? It was right? Huh? It was already right. So it's not working. It was already right, but it put it on the left. Oh, wait a minute. Wait a minute. I print 8 spaces before it, right? So this whole thing is also printed here. Are you telling me that my previous length of 24 is 1, 2, 3, 4, 5, 6, 7, 8, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I should have 4 spaces in front of it. Oh, minimum. Oh, sorry, maximum. Right. Okay. And we probably should remove the prefix from the. So the set width. I can indeed move this to the left now. And do that here as well. What am I doing? Prefix, standard left stuff. Prefix, standard left stuff. And then maybe we should put it back to the right. The right is apparently the default. So this is right, and then we do left, and then I print this left aligned, but it's just a new line. It shouldn't matter, should it? So now this width separates us from the next, and this one separates us from the next, and this separator is not very useful anymore. So I can delete this, and I might as well end up with setting the stuff back to standard right. No, it's not really necessary. Well, you don't know that, because in debug output it's not necessary, but let's be nice and put it back for whoever is the caller. Yay, now it works. I'm gonna give a thumbs up here, because it was right to say that it's smaller than the actual string. And I still didn't solve the fact that... Okay, and now I can't stop myself from adding braces around it. It just looks so nice. Hell, I want round braces. I have stuff in probably brackets. It's not really a bracket, of course. Or is it? Multi-brackets. Yeah, these things here. Curly brackets. But then without curly. I don't want the curly brackets. Parentheses. Okay, what's the multi-line stuff? Upper corner. Okay, what about I search for upper corner? And then you get only the square brackets. Nonsensical. Parentheses. Here it is. Upper hook. Now it's called a hook. Whatever. This is what I wanted. Awesome. But still identity matrix, yeah. So why? fix that. Because I'm not doing anything. The function is empty. Yeah, okay. Well, that is probably it. There we are. So now you see that the matrix indeed just got added 50-50 down there below in the bottom left corner-ish. And then the draw origin in show coordinates is now 50-50. And then of course I don't want to use 50-50, I want this thing now centered in my window and then draw the coordinate system. Centered means, I don't know, another coordinate transformation? What do you think? Yeah. Theoretically, we could use a coordinate system that has the origin in the center of the window. Draw relative to that. But then we'd still have to convert that to the actual coordinate system of the window. I could make a window coordinate system. And put the show on in the middle. obviously in pixels. Now this one, since you have these two separated anyway, do I want to have my show in pixels or not? Yeah, probably, because it still gives me most. Yeah, I don't know. I could make it from -1 to 1, you know, like that. -1 to 1 is the whole window. Actually, not a bad idea. Although that's only really going to work if the window is square, unless of course I just define my window is at most wider. So let's say the height runs from -1 to 1. And then I keep the aspect ratio the same. So this is a coordinate system, the origin in the middle of the window. Vertically running from -1 to 1. Okay, that's how I define it now. Now we're going to need some cons expression things. So I do a cons expression for the height of the window. We call that window height. And that's in pixels. And I define that as 450. And you have a cons expression in the window width. And that was 600. And then here we defined transforms. I guess I can define the transform before I define the point. Let's move this down. And this uses a print on, so we have to do this before defining that, but might as well move it to the top. So it's still a little bit more out of the way. Oops. And this one as well. More at the top. Okay, so now I want to define a transform, which is very fixed, so I might as well do that globally. I'm not sure I can make it a cons expression. Well, I could, but then this must be a cons expression, and that is maybe not possible if that is not a cons expression. I doubt Q transform is a cons expression. Has a cons expression. Constructor. But hey, maybe it does. Let's try it. So I'm gonna define a cons expression transform. And now I need to transform eventually to window. Yeah? So let's say from show to window. I really start to hate it if I have to put that in front of it all the time. So I think I'm going to remove the class here. But that means that you have a collision with draw. So this gives this drawer a different name, I think. That's a GUI window drawer. So let's call this GUI window drawer or something. Not even. I can just draw a line. You mean we have lots of lines. I have lines in the plot as well. We don't use it anyway, so I might as well call this just line. So you have a line in the shape. Let's add those as well. And a line style. Oh, I don't know, I forgot the draw. I'll do, yeah, no, yeah, well, maybe I still need it. Shape style params. Well, I'm gonna call this CW draw. Okay, window draw. Probably need it for this one. Good, the shape style params, yeah, why not? I already have a style here. Shape style params. Only one left. Okay. What is CW draw? No template name the point. Oh, I do have a point. Transforms can multiply that. Well, and I insist on having transform first. So then I have to for declare it maybe. And then we can't not do this anymore, of course. So this now must be out of line. Transform member function. Expected unqualified ID. Yeah, well, I was working on that. Okay, it compiles. Then I want to define this one. And, well, that is show transform window. That's not, that doesn't look right. I want to go to window, obviously. this is from show to window. And how is my constructor looking like? I only have a default constructor at the moment. Well, then we just create a thing again like that. Default constructed, and then I call translate on that. That should work. Then translate also has to be a const expression. Oh, it already is. I made that const expression. I don't even have a default constructor. It still hangs on if Qt transform is defined as a const expression. Well, the constructor. Okay, so I want to translate that thing, and then we, as I discussed before, this is the translation where you shift the result. Yeah, so in this case, no, you don't. Well, it is the result, but after transformation. So I should think about that as a point. So 0, 0 in show coordinates, that's the origin, is now in the center of the window. So really, and then the result must be the center of the window coordinate. Therefore, this should be the center of the window coordinates. So window width divided by 2, comma, window height divided by 2. And since that is positive, you would almost think that this is a, as you see, this is a vector. It rather points from the origin of the window to the origin of the show, where it is being showed in the window. But yeah, confusing as hell. Let's see if this compiles because of the const expression. No, you cannot use const expression. Wait a minute, it's not an aggregate and there's no const expression constructors. Yeah, well, maybe. I think the reason is still the member, but no. Maybe you have to explicitly call it a const expression before it is. I doubt that though. So default constructor, but now it is a const expression, and now I should complain about that not being possible with Qt transform in it. Yeah, see, Qt transform is a non-literal thing, and aka it's also not defined as const expression. So we can't do this, and therefore we can't create a const expression transform, and therefore this cannot be const expression. So this is not a const expression. And though we just make it const then instead. Const. Could also make it static, but why would I? Not going to link this thing with any other file anyway. Static for globals mean don't use globals, but if you do, then it should be something that is compile time constructible, aka const expression. And this is not the case. So now if we would link it with other translation units, you have no idea in which order they are going to be constructed during runtime, which is why you should not use globals. However, if you make it static, then you know for sure that no other translation unit is going to use it. Well, for sure, you could still have a function that has a pointer to it, or a function can be called from another translation unit, which then in that function you use it. So don't use globals. But static is then the most logical thing. after, you know, you're being an asshole and use globals anyway. However, static for that reason also out these days. You should use anonymous namespaces. So I don't want to type static here because it just looks wrong. So I would have to wrap this in an anonymous namespace instead. And that then tells me that I just changed the linkage such that no other translation unit can reach it, which looks also weird in my eyes because I only have one translation unit. If you get what I mean. So yeah, anyway, this should compile. And I've been using runtime constructed globals here. So yeah, absolutely horrible. But only one translation unit, so it's okay. Yay. Now what? Now we're going to use this thing, of course. Okay, construct a window. Window width. Window height. So I have a draw origin here, and that is the origin. I don't have printed, it's just 0, 0. And I want to get the show. So we have to translate that a little bit out of the center now, because it's in the center, right? And let's shift it the half the width of the rectangle. So minus rectangle width divided by 2 minus rectangle height divided by 2, which we don't have to define. I might as well make that global as well, because we're only going to have a single thing, and that is a rectangle. It's true. Rectangle width 200. Rectangle height is 100. Now yeah, we can print that. And then we can create this. We can create the draw origin, convert the draw origin into show coordinates. But that's not what we can print. We have to convert it one step further to window coordinates now. I thought this to be confusing. Let me just comment it out for now. Here we are. Rectangle. I'm creating a rectangle from show coordinates, and this gets annoying as well. So let's do. I want to create a rectangle. I want to create a rectangle called. Do I even want to create a rectangle? Actually, I can just put it straight in there. Yep, let's do that. This needs a rectangle, so I'm going to give it a rectangle, and I want to create my rectangle from two points. No, from a width and a height. Actually, I want to convert it as well now. Let's use 2 points, or let's just create a... I need a rectangle, I think, next to my point. What would be the easiest way? The easiest way is to just pass whatever they want to pass and then let it automatically convert it. I don't even want to be bothered with going to window here. I'm just gonna do the show thing. So origin, show origin, and then show what was this called? The size, I think. Qt calls it a size, I think. A width and a height thing. And I call the thing itself, I call it a rectangle now, but I was calling it an object before. Yeah, object. So maybe object size. Object size in show coordinates and the draw origin in show coordinates. And now we construct from that a rectangle that can be passed to a shape. Ta-da! I think it looks awesome. Okay. Therefore, we no longer have a show object, we no longer have a rectangle. And this is then the combination of the two. So this is a draw. The rectangle. To the rectangle of show object size. At the top left in the origin of the draw coordinate system, which is draw origin, obviously. So this is where we want to go to. Well, that definitely means we need to define a new class here, because I don't have a rectangle that can be constructed from that. And that rectangle then has to be derived from the rectangle that we can pass to a shape, which is this rectangle. Okay, window rectangle. So this rectangle here is no longer this rectangle, because that's a Cairo window rectangle, so we have to remove this. And then make a new rectangle that is derived from that. I'm going to put the rectangle here, I think. So we make a class rectangle derived from a Cairo window rectangle it was. And my rectangle can be constructed from currently the only thing I need is show coordinates. What am I passing? A size and a point. So I still need to define the... This becomes a template. Coordinate system point. Origin point, top left. How should I call it? Top left. No, it's nonsense. We have only one coordinate system. So coordinate system. And then here we have a point. using that coordinate system, and that is the top left. I would almost say it's bedtime, but I just... No, it's not. It's afternoon here. And then I need to define another thing, a size in that coordinate system, which is the size. Good. And then we need to construct the rectangle. The base class, yeah, that's not that easy because I need to do a lot of stuff. This thing takes 4 coordinates, I think. Yeah. Yeah, width and height separately. So I need to convert my point to another coordinate system. So it is top left times my global conversion here, window transform. Now to do that multiplication twice, I don't like it. Yeah. Actually, so this must be show. It must be show. Oh, it's not a template. Can only construct it from the show coordinate system. Now if I want to be consistent, then I have to tag show in front of this now, because we know what it is. It is the show coordinate system. And then after this multiplication, I have it in window coordinates. And then we need to access the x. You see, and then I have to do that multiplication again, which I don't want to. So I'm going to add a new class. Let's call that a struct rectangle base, which is not derived from that rectangle, which is going to do all the hard work. Rectangle base. And this is going to have well, whatever I can pass here, which was this, no, all doubles. No, that's nonsense. Doubles. Just Q reals. No, I just need a point here. Yeah. Yeah, of course. So we make a point. Top left. Let's write it like this. And the size. Show coordinates. And again, this nonsense. These are window coordinates. Let's call it not base, but let's call it to window. So I have a constructor here which takes the same things, and I'm gonna pass those to the first base class as is. And then after that is constructed, we're going to construct this base class, and that base class then can simply use the other base class. Okay, read it. So we split it up here, but you don't have to do the multiplication twice. Multiplications twice, rather. Yeah, looks good. Missing here is size. I just pulled that out of my head. So besides point, we now need a size. And this is probably just copy paste stuff, apart from the final implementation, because it's almost the same as a point. So I make a for declaration for size, and then we need to be able to transform that, so multiply a size with the transform, or the other way around. And then we need to implement that. I need to write the size itself. Okay, so here, copy point. Call it size. Let's not do a default constructor, because something with the size of 0, 0 is not useful. And I don't know what units we are using here. Well, actually I do, but I don't know. Let the user just pass it. And then it stores a width and a height. Which is being passed here as well. Width, height. We probably need accessors for that. Probably. Don't totally need accessors for that. Already used them even. Okay, I can't type. Help. Undo. Height. Width. Height. Never use abbreviation. See, well, actually X wasn't used anywhere else, and Y neither, so I could have done search and replace. Now it's too late. Now I'm just gonna type this. Width, height. Totally the same as point, but just with width and height. Now this one is slightly different, because you don't want to do the translation. I just want to resize it. You cannot have rotation. That's where I am multiplying it with a coordinate system transformation. I can just ignore translation because we're talking about the size. And I think I should ignore the possible rotation as well. Right? I mean, isn't that the definition of a size? Like, does the size of my rectangle change if I rotate my coordinate system? Depends how you define it. You could define it as a bounding box, but then the bounding box is translated as well, and I definitely don't want to take translation into account. So I think I'm just going to ignore the rotation as well. I just want to have the scaling. Okay, so how do we do that? It's not really a point. Does Qt have a size? Yeah, it should have a size. But I got the whole idea from Qt. So Q size maybe? Does that exist? It does exist. Great, great, great. We can scale it. If you call scale on it, then scaled, set height width, shrunk by Q size. That's the integer size. Oh, they actually have documentation. Wow. Yep, okay, we have to do this. So I need to create my Q size F from the original size. And then it's not a point, it's a size. And then we do size scale something, and then we return that. Oops. And the thing has also a width and a height, I think, accessors. Let's see, go back. Width, height. Yep, yeah, width, and then height is somewhere else. Now here's height. totally have that. Okay, and scale is working as follows. Well, we want to scale it, whatever. I mean, I'm keep aspect ratio or no, I don't think so, because well, my transform is going to be such that it will keep the aspect ratio. But if that was not the case, then who are we to suddenly change the actual size? Plus, now I think about it, I was going to have an example where the aspect ratio is not kept. So let's just scale it exactly. So how do we scale it with, I think dot M11, comma M underscore dot M22. What kind of scale is this? That's not a multiplication with 60. That would be 600. Oh, wait a minute. T1 is that. No, T1 is this. It's the size. So I don't get this at all. It's not a scale. It's set the size to 60. So this calculates that this one has to be scaled up by 6 and this one has to be scaled by 5, and therefore it picks 5 for some reason. So okay, yeah. So this one, you ask for 60, then the largest one is 60, and the other one is reduced to keep the aspect ratio. And here you have you ask for 60, and now you get at least the correct thing, and the other one is then expanded. So this one becomes 72. It's not a scale at all, man. I might as well just set the width, which is actually then the same as this one. So this is not scaling. This is just literally change the size. What the? Who made this up? Scales, yeah, not really. The size to a rectangle sets the size of the rectangle to a given width and height. Very far-fetched. Let's see if there's one that makes more sense. Set height and set width. Like that much more. Or just construct it from height and width. Yeah, okay. Why would you even use Qt's size if it doesn't provide anything useful? So let's not use the Q size F, it's just nonsense. Go straight to size. I don't know whatever what. Let's see. It's not called rectangle base. I renamed it to window. Use of undeclared identifier is show object size. I don't have that defined, I guess. Okay, we have an I want to keep this simple, therefore right here you have a global thing here defined directly from window height and window width. And I'm also going to construct an what is it? Transformed. Oh, it's not really what I have then. Now is it? No. Okay, let's leave it like that then. So what I know is the size in window coordinates. I already know that. Because it's... Yeah. A bit silly, but okay. So construct this from rectangle width and height. But we need this. So that would be a size. Show coordinates. That we can construct from this. But the transform that I have is this one only. No, I have another transform. This is between, sorry, that's between show and draw. We have the other transform. It goes from show to window. So if we multiply this with that, then I get this. So then I guess I have to divide this one by what I otherwise would use to multiply this thing with. Transform window. No, transform show. That thing is defined here. It is just a shift from the top left of the window to the center, or the other way around. And that scales nothing. So this currently, well, actually I'm going to make that do something, but at the moment it doesn't scale anything, I think. Plus it's not true, is it? Wait a minute, Windows will, yeah. Huh? Yeah, at the moment not, but it should. Anyway, we're going to divide by that, I think, yeah, because it's not entirely correct, is it? What you really want to do is multiply, let's say, what we know is that this times that equals that. Because now I can short circuit the shows and then we are left with the window. So this is a window object size. And this is a matrix, so we can multiply both with the inverse of the matrix. So this size and that size. And then this drops out. Wait a minute. Multiply this whole thing. So we multiply this with the inverse from the left and this with the inverse from the left. And now these drop out. So this is the correct formula, not this. Now a division is defined as the thing that you have to multiply this label with in order to get 1, where 1 is in this case the identity matrix. Therefore this is defined as the inverse of the matrix. Multiply with the inverse of the matrix. That's what the division is, period. So we multiply from the wrong side now. Or do we? Yeah, we do. But if you inverse this matrix, then the window and the show will swap. So then we suddenly have the show on the side of the window. You can't even multiply this. So I think the notation is wrong. If I would just use a division, I don't like to use the wrong notation. So we're not going to do. We're not going to define a division by that, like that rather. Instead, we need to have an inverse. And then multiply that with the Windows object size. The downside of that is that Qt provides a way to do that faster. I don't have to first calculate the inverse and then do the multiplication. If we know we want to do this, we can just say, hey, here's the transform, here's the object, do this. So the way around that would be to have inverse simply wrap the transform, only change the type. And then have that type, give that type a multiplication object, a multiplication operator. And then combine the whole thing, if you get what I mean. So I need an intermediate inverse transform type now. And yeah, that kind of doesn't make much sense. We could just extend this class with an extra parameter called inverted, which by default is false. And then I add an inverse here. So we're going to return a transform to CS from CS, not inverted. And then I need to be able to construct it somehow. And I just want to construct it from a Q transform. So I think I'm just going to pass M here to that type, which is then a bit tricky. So that should probably be a private constructor. So now you have this transform here, which takes Q transform. So we do make a copy because this is returned by value, which it has to be. You can't return a reference to ourselves because we want to change the type. We don't have that type, so I have to create this type, but that type then is I could return a const reference to ourselves and then cast it to this type. Then I don't even have to make the copy. How dirty is that? Since it's a const reference, that would even keep working if you change the original. Then it's pretty dirty, but I'm going to do that. So we can just return this and then return a const reference, I mean, and then return our cells, but change the type. Static cast. This is static cast, right? No, it's totally a reinterpret cast. This interpret cast. But yeah, 0 is assembly instructions. It's just a type change. And if you call that twice in a row, then really you have our cells back again. Right, and then we need to implement the multiplication. We have two multiplications here. Both need to be changed because these multiplications only do only the correct thing if inverted is true. False, I mean. Well, they're still the same. Now I think about it. Wait a minute. Here. So we do if const expression not inverted. Then we do that. This is the other one. Otherwise, and now shockingly, it's just a division. But that's because this is a scale, of course. The other one is more interesting. That's why we did it like this. Okay, we have a point, and then again, if not inverted, we do this. Else, we do something else. Or you call directly. So it's still an inverted version. And I thought that was not necessary. Oh well. Oh well, it's still there's still a good way to do it. Just one in one line now we have inverted, and then we do the map. No matching constructor initialization of transform window show. Is a single argument m. I lost my default constructor. Yeah, added this constructor. Now, therefore, we don't have a default constructor anymore. What is this? Just a typo thing? Oh yeah, okay. You have an extra template parameter now. Inverted. Value of type window. Okay, career window is not implicitly convertible to coordinate system. Ouch. Collision with window as well. This thing. Cairo window, my window, project window. My window. No, over my dead body. No, okay, no truck came riding into my living room. I looked. Let's see, how call this thing? Oh, you don't understand anything? Well, you can help me with telling me how to call this window. It's the window, you know, that we open on the screen. I really can't think of a good name. Call it Win. Seriously, it's pathetic, but oh, it's not a place where we actually run the thing. I'm writing an app. Yeah, no, not an app as in Android, but a program. I can show you in a second as soon as it compiles again. No member named inverse in ChatGTP. Oh, actually, it's me. It's not ChatGTP. Inverse. Yeah, I think I called it invert. That's not good. Invert is not good. Let's call it inverse. Inverse. And we're trying to... Oh, wait a minute. No known conversion from... Dude, what are you talking about? You just can't multiply, I suppose. Error. Invalid operand to binary expression. It doesn't even mention which binary expression. It just points to it. And the things that we are passing is a transform to one not false. Brilliant. That's inverted thus, and this. That's a size in window coordinates. So I just skipped all the user includes. Now we get to the real stuff. Candidate function not viable, no known conversion from cont size window to cont point. There's the problem. We have a different coordinate system. Yeah. So this compile error saves me from accidentally using the wrong coordinate system. It's the whole reason why we wrote it like this. So this type really depends on whether or not it is inverted. Well, both types actually. So I need a selector depending on inverted. How do I do that? I'm afraid I have to ask ChatGPT. It's an easy question, so let's ask it here. What type traits, which is a header by the way, allows me to switch between two types? Did I already show the types? I did not show the types, so between two types. Using the const expression boolean inverted. Conditional. Standard conditional, inverted, inverse type, normal type. So the actual to type is just call it convert to. So if they are not inverting, then this is the type. And it is then obviously the to type, and then the other is the from type. Oh, wait a minute, it's not a type. It's an enum. Okay, sorry. Well, I don't have to ask then. I know that one. Hey, okay, so yeah, it's really, no, it's convert to. I'm afraid this is going to be a static const expression then. Static const expression coordinate system convert to is simply inverted question mark from and otherwise to. Let's redo it here, I think. Here I might be able to use the class itself already, I'm not sure. Let's try that. Convert from. It doesn't accept it. But surely I can't use convert to here. If I can, I am surprised. Pleasantly surprised, but still surprised. No, I cannot. I think you have to just spell out the whole class again then. Okay. Now let's run the thing. Just a few. Where was it? No, still not. There it is. Well, it's nicely centered, but it's not what he wanted. Ugh. Or is it? Yeah, actually it is. No, it totally is. Yeah, I want it to be centered. So here we have a rectangle, 200 by 100, and it's centered. Which is like, oh, did you have to code 3 hours to get that? No. The nice thing of this is that we have a coordinate system here that has origin here. That is the origin of a non-visible coordinate system. So I can draw, I should be able to draw a line now through the origin. Yeah, these are show coordinates. So that is the origin of in draw coordinates, the origin of the draw coordinate system, I mean. In show coordinates is -100, -50. And the show coordinates have the origin in the center, that is here. Therefore, and the scale is still 1. Therefore, if we go 100 to the left and 100 up, then we reach the origin of the draw one. So this is 200 wide. So we go 100 there and 50 up, and then we are in the origin of the draw coordinate system. So I did the right thing. Now I'm not sure, am I using show coordinates at all at the moment? I don't think so. I'm just calculating it. I'm using the center. That's the only thing I use. So I think I'm creating, use the default constructor somewhere, and then we have the center and the center of the, yeah, okay. So we have show something. This can't be correct. Probably not even using it. I'm using it here. Okay, the size of the rectangle in window coordinates, which means pixels. Maybe I should not have renamed my window to win. I just should have renamed this to pixels or device. Window. Oh, right. Now I remember. So at first my show was the window, and I didn't want to use window because then I would get confused with Qt window things like the viewport. And then I did split the show coordinates with the window. But show really means like the final thing. I think this should be show. And this should be like now maybe centered or something like that. It's nothing to do with showing. Yeah, let's rename show with centered, because that's what it is now. Yeah, well, every show that I have is this show here. So file wide, replace show with centered. And maybe replace the window with pixels. Except those two windows. And except this. There's not everything, and definitely not that. Maybe more care. So let's call this pixels. Window, 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 window. Yep. Let's do this one line then. Substitute window with pixels. And then here again, I suppose, and not that one, or this one. We do this one. Substitute window with pixels. Not these. Not those. Window, window, window. Here's another window that needs to be replaced. Pixels, and then we're done, I think. Yeah, back to the top. So I have in pixel coordinates the rectangle, which I call object size here, or I call it object, and then the size of the rectangle is object size, and I use a rectangle anyway. Shall I replace that rectangle with object then? Because I wanted to stay away from the word rectangle for some reason. There's another rectangle here, which happens to be the exact same rectangle actually, but still, you know. It's more an object. I mean, some point is rotated, and I hesitate to call it rectangle. Is in the sense that if you draw a rectangle, it's going to be aligned to the x and the y axis, isn't it? I don't know. I'm not using object a lot, so if I call it object, then it's easy to rename it again to rectangle. And the other way around, I'm not so sure. That's a good reason to call it object. So how many rectangles do I have at the moment? See, I have a rectangle with a capital R, but that's definitely a rectangle. It's derived from Cairo in a rectangle, so that is a rectangle, like you've never seen rectangles. But the lowercase rectangle, which I now can't find anymore. Here. Yeah. That one is used for the width and the height. With height. The rectangle centered object size. Let's call that also object then. Object 1. See, draw rectangle. Yeah, that must stay a rectangle. And this can be object again then. Substitute rectangle object. Good. So again, the size in pixels of the object defines the same size in the centered coordinate system. And we didn't scale there, so this doesn't change the thing at all. But that's what it should be if it is scaling. I think I'm gonna add that. The scaling, I mean. So let's print that size, so we can see that it gets scaled correctly when I add scaling. So the centered object size is centered object size. Then I define an origin in draw coordinates of the draw. This is just default constructor and it gets 0, 0. And then we convert that creating a this doesn't read well, does it? Make an identity matrix for the for a conversion from draw to centered, and then tag and translation onto that. And then nobody knows what these are. Which coordinate system is this? I think translation happens after scaling. So probably we scale first and then we add this. Therefore, these are window coordinates. No, we go from draw to centered. See, this doesn't make any sense whatsoever. Oh, no, it does. Sorry. I'm looking at this and all the time I'm reading window width instead of object width. No, of course. This is just the shift required to have the object centered. So probably should see. Yeah, these are centered coordinates, I think then. But these are not centered coordinates. Object width is in pixels. It's a bit risky, I think, to use this here because this is not tagged with which coordinate system it is in. I think it now works because the scaling between those two coordinate systems is 1. But we should not be using these constants in more than one place probably. So I have the other one as well for the window. They have a width, object width, commented out. So we have a window width and an object width and the height. And for some reason these are like that. Yeah. Pixels width. Oh, that won't compile then. Huh? What is pixels width then? Oh, that was window. Yeah, so that should not have been changed. Start from the top. Okay, window object. Window width is being used here. This should be the last place where I use window width. Let me just search for that. Oh well, not the last place. defined, used for a transformation, and the actual window, and that's it. Very good. And then the object height is defined here, used for, well, entering the coordinate system stuff, and that should be the last place where it is used. But I'm using it here as well, so I should not. Instead, we should do a translation using this divided by 2. I can just scale a size, right? So I can do a scale with a factor of 2. Okay, so let's translate. Just take it. Okay. So non-PG. Take this pixel offset size. Yeah. Divided by 2. And I think it was negative. Negative. Okay, I'm just gonna do a multiplication, I think. So I scale, multiply the size with, and then we have a size that is negative. But yeah, what can we do? Translate by a size. It's kind of weird, isn't it? Nah, I don't like that. Damn. I can multiply it by a half. Arg. Let me see, rethink this. So if you have a transform from draw to centered, then the translate must take centered coordinates, I'm pretty sure. So now, besides we have a size and a point, and now we need a vector. Oh, God. Seriously. I'm so tempted to use point or size. The vector, is the vector subject to a transformation then? I guess not. Not really, no. Well, if it is a true vector, it would be. And then the vector is just a wraparound point. No, this, no. The translation vector is pointing from the origin of one coordinate system to origin of another coordinate system. How are you ever going to want to transform that? I mean, that makes no sense whatsoever. So I'm going to introduce a vector which is actually a translate vector. Translation vector. So I create a translation vector from a size, which then inherits the coordinate system from it. So we know that it is in pixels. And then multiply the vector with -1/2. Which is, of course, totally okay now. And then we need to define the translation vector object. Yeah, and then the result will be that this doesn't compile, because now this is in pixels. Therefore, this is, pixel coordinate system. So the vector is pixel coordinate system, and the translator is going to say, I want draw coordinate system. No, I want centered coordinate system, not pixels. Jesus, pixels. This is from draw to centered, and I'm passing pixels coordinate system. So unrelated. So yeah, that would be a good thing then. Eventually this has to fail compilation. And for that to fail, we have to add a translation vector that keeps track of what is what. And that thing is very much the same as a point, but you don't need a forward declaration here because we cannot transform it. Just add it to the end, I think. Rectangle window, rectangle. Yeah, nah, a bit too low. Let me add it under the size. So we make a translation vector which is aware of the coordinate system that it deals with. And then internally we store a vector. Ta-da! How shall we store the vector? Just X and Y. I have my own library, of course. I have loads of vectors. Vector Cairo window vector we have. It's a math vector. I could use math vector. Let's see what that is defined like. Intersection points. Utils vector. No math vector. Well, boomer. It does know about math. Math. Point. Trackable. For declaration. Oh, I don't have a math in my search thingy. Just .xx and .h. Math. There's the math vector. Totally two-dimensional, so will very suit our purpose. Although it's doing a lot more than we really need. But you can multiply one vector with a double. Ta-da! So the -1/2 has been taken care of here. This is like literally multiply -0.5 times the vector. That's gonna work. Probably even here. Double. You can multiply it like that as well. I'm still looking for the thing that I really use. Or Well, no, it must just, you know, exist. I'm gonna use a math vector. So we wrap this around the math vector. And that's our translation vector. Public. And then we had a constructor that took a scale, I think. Let me see. Translation vector takes a pixels object size. It takes a size. So we can construct it from a size, and then I just fill my translation vector in with the size x and y, width and height, I mean. Because that is just a sensible thing to do. And we now have our coordinate system in the type. Might as well add a point as well, because, well, why not? If you want to construct it from a point, then so be it. Just do your thing. Can define it the way I want. Could add a minus signs, swap x and y. But this seems to make a lot of sense, right? Yeah, and then we want to be able to multiply it with a double. Might as well define that here then. Now we return this by value. Yeah, just the way it is. So this is a friend operator multiply double scale. And then our cells. Translation vector. You will never be able to watch TV again without thinking about this stream. Television. Yeah, okay, return. So I also need a constructor, which is then probably private, right? The same argument as before. From the internal thingy. Which we then use here. We're gonna pass here a math vector, and that the math vector already knows how it can be multiplied with the double from that side. And then translate, of course, must take a translation vector. Oh, translate is all the way out defined. Yeah, much higher. So maybe I should move my translation vector up. But. It's using a size and a point. Oh well, let's for declare then. Put it happily here with the rest. And then have a translate. A new translate which takes an Oh, changes the current object. Oh, okay. Translation vector. Constant reference. TV. So the coordinate system that the translation vector can be is the result. The translate result, which means what we convert to, that is this one. Because it depends on if we are inverted or not. That means, yeah, if the transform is inverted, then and you call translate on that, then it stays inverted, but we just the input and output are swapped basically. So the type is different, or the enum value is different. And then this must be defined below, where we can use point and scale to somewhere here or lower. Oh no, even lower, translation vector. So this would be good enough here. And it is yet another transform member function. So we get the template, and we get the template parameters. And we get the scope thingy. And then we can implement it. And we change ourselves. Dus in the end, they return this. And then here we do a map, I guess. Is it true? No, I don't. Nonsense. Translate over a certain distance on M, which is Q transform. It's the same as this. So I might as well call this and then pass the... actually I have to delete this now, because I didn't want to pass stuff that doesn't know which coordinate system it is in. So I'm going to delete all this. You don't want to use that. Okay, what? Yep, apply the vector on the transformation matrix. Yeah, rotate specifiers blah 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 blah. What is it talking about? Template clause. Too many arguments, a function call. Oh, the translate, yeah. So are you still using a translator we're not allowed to use? Right there. Interesting. This is kind of the same thing. So we must pass something times a half, where the something is in Windows coordinates. Actually in pixel coordinates. That is accepted. So we need the window size. I mean, this is in pixels. I'm not sure. Well, I don't have the size defined yet. The class size. So where exactly is this being used? In the rectangle window, which is pretty far down, so almost before main. So we can move this down a lot. And then I can define here the window size. Wait a minute, I call that pixels. The size in pixels, and that is then my window size, defined as window width, window height. And then I'm just going to use that here, like a half times, and now this thing only takes translation vectors. So translation vector constructed from the window size times a half. Or I can define half the window size here and then just pass that. Because this thing will want to take a translation vector with pixels as coordinate system. So if you pass a size with pixels coordinate system, it's going to say, you know what, okay, I'll just convert it into translation vector. And I think that reads better. So let's say half window size 0.5 times 0.5 times, and then we just pass half window size here, and then the conversion to the translation vector will go automatically. Or not. Expected unqualified ID. Oh, missing class here. Yeah, then it won't work. I don't even have that type. Incomplete type math vector. Missing header. Where's my math vector? It is obviously defined in math vector. Doing this wrong, right? I mean, no, doing it correct. Yeah. No, wait. No, it is correct. The order is correct. From new to old. This is invalid use of non-static data memory translation. It's in the TV. In a friend. No viable conversion from translation vector 2 to translation vector 1. Hopefully that is the line that I wanted to not compile. And I think it is. So we succeeded in detecting that here we're trying to pass the wrong coordinate system. This thing takes, to be able to see that here, Well, it takes 1. Bit disappointed it doesn't print a enum value. And the AKA is wrong as well. Looks like a bug. I think this is supposed to be the enum number, but it's I don't know what that is. Oh, that is an enum number, but yeah. No, whatever. So 1 is, you have to look that up. 1 is centered. So it wants to take centered, but we are passing number 2, that is pixels. So we need to convert the pixels here to centered. Let me just make it centered then. Centered object size. Already have a centered object size. So I'm just passing the wrong thing here. Centered object size. No member named X in translation to vector. You don't have any accessors. It compiles. I think there's not going to be any difference. Just still a centered square. But now I can add a scale and still have the same thing. That would not have been the case without this change. So I want to add a scale so this comment is correct. This one. So my centered coordinate system should have a scale relative to pixels. Because I wanted to have a height of 2. Still centered, but a height of 2. This here is our transform from center to pixels. And I added the translate. Now the translate should happen after the scale, because this is in window size. I'm not super happy with this. But okay, it should work if I do the scale first anyway. Let's not make it too difficult. And the scale then must be half the height. Or the other way around. It's from center to pixels, so it must be larger than 1. So it's just the height, the window height divided by 2. Can just take the half window size here as well. And take the height of that. I don't think my transform has a scale yet though. So here we have a translate. So we don't have a scale, huh? Don't have a scale. Okay, let's add the scale here. Already. And this is just a vector. This really has no coordinate system attached. In the end, it's gonna convert it to a QReal anyway. It's just, I think that is a float, but well, I don't know. M, yeah, same thing. I think we just call scale on it. Oh, that won't work. Where's my scale? Yeah. So I need this to be added to the class on top of the translate. Size, point, translate, scale. Mm-hmm. Too few arguments. Drum ruffle. Will it still look the same? Probably not. Nope, it's gone. Uh-oh. Well, I think it's time to go eat. What went wrong here? Okay, I'm gonna make the decision if I quit streaming right now and go to the shop based on how many viewers I have.